I'm a happy camper. Just got a fresh cup of coffee. So far to date, I have received $0.00 from Dunkin' Donuts, but I continue. Actually, I must be at negative because I just keep buying their coffee, so whatever. Day 4, kids, day 4. I'm so excited about day 4. We are going to talk about normal distributions. Oh, almost lost my coffee there. That would have been bad. Clearly, one of us is not normal. I'm talking about you, of course, not me. But we're going to talk about normal distributions. Some people like to call these the bell curves because they sort of look like a bell. Don't do that. Don't like bell curves. Don't like the name bell curve. Maybe somebody likes it. I don't know why. I'm just not a big fan. By the way, all these videos can be found at www.nkinfinity.com. N stands from Fräulein Newman. I am Herr Krause vom Nachbarhause. Lies a bisschen Deutsch für dir? Actually, you can just call me Mr. Key. Natürlich, ich kann Deutsch reden. Aber nur ein bisschen. Ein bisschen. That's all those Swabish for you. Anyway, let's talk a little warm-up from yesterday. Not a warm-up. Let's just talk. Remember we talked about center, shape, spread, and outliers for yesterday. Well, today we're going to talk about that for a normal distribution curve. The center is clearly symmetric. Clearly symmetric. The center, in this case, would probably be the mean. If it is truly normal, the mean is a fantastic indicator of the middle. The median would be also fine because it's going to be, if it's normally distributed, they're going to be almost exactly the same. The spread is fairly compact. And we'll use the standard deviation for that. So either use the population standard deviation or the sample standard deviation. And outliers, generally I guess outliers for a normal distribution would be, let's say outside of about 2.5 standard deviations. Let's see, 2.5 standard deviations. That would be out here in the 0.6% range, or over here in the 0.6% range. So if you're out there in those 0.6% range, you're sort of freaky tall. You know, it's probably, maybe I should use 3. It really doesn't matter. We'll still use the 1.5 times the IQR for most of these to see if we do have any outliers. Because even though something's normally distributed, you still can have outliers that are trying to mess things up a little bit. So if you look at this normal distribution curve, what you'll find is, if you took your calculator and added all this stuff up, what you'd find is that the area under the curve would be 100%. You know, simply stating this and this and this and this and this and this and this all add up to 50%. So 50% would be below the mean and 50% would be above the mean. So we got 50% of below, 50% above. Now what these numbers on the bottom represent are standard deviations. So these numbers down here are called standard deviations. Standard deviations. How far away are we from the mean? So if I land right here, I'm directly under, or I'm on the mean. If I'm down to here, this would be down 1 minus 1 standard deviation. This would be plus 1 standard deviation. So when you do this, you're trying to find the actual area under the curve. So what is the area under the curve when I go 1 standard deviation down and 1 standard deviation up? If I added all these areas up under the curve, what you'd find out is you have exactly, or almost exactly, 68.2%. So what does that mean? See that double entendre, mean? What does that mean about the mean? That's so funny. What that means is this, is if data is normally distributed, then if I go up 1 standard deviation or I go down 1 standard deviation, I will get 68% of the population. So let's say I had a test scores in my class and they were normally distributed. If I found the mean or the average and I go up 1 standard deviation or down 1 standard deviation, almost about 68% of the kids would fall in that range. Then you'd have some be above that and you'd have some be below that, but about 68% of all students would be in that range. If I went out another standard deviation, so I went out to 2 standard deviations, so I'm going to add a little bit more, I'd be up to 95.4%. And these numbers are kind of important. They're standard numbers, 95.4%. So that means if this is the average, I go up 1 standard deviation, I hit 68% of the kids. 2 standard deviations, I've got 95.4%. If I go out 3 standard deviations, I get 99.8% of all of the kids. So if I go out 3%, I'm going to get everybody. I'm basically getting everybody. So anybody that's even past that or remotely past that is probably going to be some kind of strange outlier. You know, the kid that's blowing the curve on the test. And so that's the basics of the normal or the normal or standard the normal distribution curve. This is the normal distribution curve or standard normal distribution curve with the standard deviations. All right, these are the percentages. Hopefully, you've done a little bit of this in the past. So let's get started on working on some example problems on how we're going to use that normal distribution curve to our benefit. And I'll do that in just a second. Okay, let's see if we can figure out how the normal distribution curve works in an actual problem. Or at least, let's see if we can figure out how we put the numbers in and see it kind of makes sense of what's going on. So let's say I say the mean height of a normally distributed, and that's important wording. If you don't see normal distribution, you're not allowed to use this normal distribution curve. Most of what we're going to do this year will be normally distributed. So if a mean height of a normally distributed, and I'm going to highlight that because it's really important that they see that, population is 138 and a standard deviation. Determine the heights for the 3 standard deviations within the mean. So how this works is this. This center number here will be the mean. And then all we'll do, and this is our x bar, all we're going to do is go up by a standard deviation of 5 centimeters. Now this sigma, this is the Greek letter sigma. It stands for the population standard deviation. All right, so this stands for the population. That means we got everybody. So whatever the heights of this population of, and again, notice I use the word population. It wasn't a sample. When I say population, that means I checked everybody. So it could be just the population of the kids in my 5th period class, and then I check their average heights. So I'm just going to go up by 1 standard deviation. So if I go up by 1 standard deviation, I go to 143. If I go down 1 standard deviation, I'm down at 133, sorry. So up 1 standard deviation and down 1 standard deviation. Now, in this area right here, which I'm going to highlight in blue, all of this, that I would expect to find 68%, 68.2% of all of whatever I just tested, whoever these kids are, there'd be 68%, 68.2% of them will be 1 standard deviation. If I go out another standard deviation, I'm at 148. And over here, I'm at 128. If I go out one more, I'm down here at 123. And I'm up here at 203. I'm at 243. I went to 203. How about this is 148. So this would be 153. Sorry, it looked like a 9 there for a second. And so again, right here, to go 2 standard deviations from here to here, I would expect 95.4%. To go from 3 standard deviations out, I would expect that to be 99.8%. And then there might be an outlier, but anybody way out here on what's called the tails would be an outlier. On the standardized test, the mean was 82. And the standard deviation was 6%. So we're going to add 6%. 88, 94, 100. Down 6%, 76, 71, 65%. Pretty simple stuff. Oh, I don't know why I went 71. I got my head up my keister. Sorry about that. I was expecting it to go to 65. It did not. I don't know why. This should be down 6%, 70, down 6%, 64. This part of it's now, oh, this one's a little bit tricky. This one says determine the standard deviation and the mean. I don't even know what the mean is. I should say what is the standard deviation and the mean for this normal standard deviation. So notice I'm telling you we went down 1 standard deviation and we went up 1 standard deviation. So right here in the middle should be something in between these two. So let's see, the difference between those two is what? 28? 28 divided by 2 is 14. So it looks like if I go up 14 and down 14, I'll find the mean. So if I go up 14, I'd have 26 plus 14. And if I went up another 14, I would have the 40. So clearly the mean is 26. Well, that's not exactly what they asked for. They asked for the standard deviation. Well, the standard deviation then would be just what is that distance to go there? 14. What is that distance to go there? 14. And this math that we just did here, this 40 minus 12 over 2, because it was 2 standard deviations, that told us we could go right directly to the answer on this case and just say, oh, the answer is 14. On a standardized test score of a score of 75 falls exactly 2.5 standard deviations below the mean. Okay, so here's the mean, which we don't know, because that's what they're going to be asking for. If the standard deviation of the test is 4, what is the mean? So, to go from there, we're going to go down 2.5 standard deviations. And I got a 75%. Now, it's 2.5 standard deviations below the mean. So I went down 2.5 standard deviations. Well, how do I do that? Well, if this is the mean and I want to go 2.5 standard deviations down, I'm going to go down 4, then I'm going to go down 4, and then I'm going to go down down 4 would take me to here, so I'm going to go down 2 more. So I went down 4, down 4, down 2. That's a total of down 10. So to get back up to here, I've got to add 10. So my mean, or my x bar, would be 85. Now another mathematical way to do this is says, okay, I know I'm 2.5 standard deviations below. So if I add those 2.5 standard deviations on, I'll get back to the mean. So I could just say, okay, I could just mathematically say, take 75 and we're going to add 2.5 times the standard deviation, which is 4. Well, this just should come as no surprise. This is 75 plus 10, which is 85. All right, we'll keep going in a minute. All right, got a few more examples on how we're going to use this. Then we're going to start answering questions. Maybe I can't get there. Let's see. Am I going to be able to get there? There you go. Determining percents and probabilities. All right, so the first part is pretty easy. Let's see what we got here. A normal distribution has a mean of 84, so mean goes in the middle. and a standard deviation of 5. And I will almost always at least write out one standard deviation. 5, 89, 79. I might go out 2, 94, 74. What the heck? Let's go out 3, 69, 99. And then this is in the mean in the middle. So what's the question say? What is the probability that a randomly selected value from a population is between 74 and 94? So I'm going to shade that in. I'll use this. 74 and 94. Well, that's up one standard deviation and down one standard deviation. And we talked already before, if we go up 2 and down 2, in between those two is 95.4% of the value should be able to be find those values, okay? Or in between those two values. That's a pretty simple one. A normal distribution has a mean of 51 and a standard deviation of 5 or 3. So let's go 51, 54, 57, 60. It's pretty easy to count by threes. 48, 45, 42. So what is the probability that a randomly select value from the distribution is at most 48? So the most it can be is 48. This is the highest it can be. Right? So it can't be any of this. Or, I mean, it can be all of this, but the highest it can be is 48. So what I'm looking for is all of this down here. Well, there's a couple of different ways to do it. You can go back to the original diagram above and see, okay, I know that on this side I got 50%. And then if I go on the top, and if I remember correctly, this one standard deviation is 34.1%. Right? Go back up here. I didn't ever add that up, but so if I just add all this stuff up on the right, I get 50% over here. And then I add one standard deviation. Remember, each of these is a half. So if I add one standard deviation, I'm adding these two together, which is 34.1%. So I come back over here and I say, okay, all of this is 84.1%. All of this on this side. I want to know what's the probability of it being on this side. So I'm just going to take that and subtract 1, and I get 15.9%. So that actually is the answer to the question, 15.9%. Or another way I can do it is I can come back up to my diagram and I can say, okay, the most I can come up to is right here. So I want all of this. And if I add all of this up, I get 15.9%. No answer key on this one. On a standardized test score of 75 falls below standard. Oh, wait, I did this one. Oh, we already did this one. I don't know why that's a duplicate. I don't know. If 95% of the scores on a normally distributed test are between, so remember, 95%. Now, okay, that's really close to 95.4%, which is approximately plus or minus 2 standard deviations. So we're going to go down 2 standard deviations, down, up 2 standard deviations. So between these two right here, I should have about 95%. About. So how many standard deviations is that? That's 1, 2 down, and 2 up. Okay. And that's, oh wait, here's 75% and 91%. So 95% of whatever these things are fall between 75% and 90%. What is the standard deviation? Ooh, okay. Well, I like to find the mean. I don't know. I always I think we should know what the mean is. So if I just figure out what the middle between these two is, right? Figure out what the middle is. So 91 plus 75 divided by 2, that will give me the x bar. Let's see, that's 166. So 166 divided by 2 is 83. So 83 is the median. Excuse me, the mean. That's the easy part. Got 83. Now, how would I find the standard deviation? There's two ways. I'm going to show you the harder way, I guess the harder way, and then the mathematical way. The harder way would just kind of be able to say, okay, how do I go from here to here? How much is that? Well, let's see. That's 7 to 90. So this distance right here from here to here is 8. So from here to here would be 4. So in this case, my standard deviation would equal 4. Okay, that's not hard, but that's one way to think about it. Another way to think about it is this, is go back to my original statement. To go from, you're going down 2 standard deviations, and you're going up 2 standard deviations. So if I figured out the distance between these two, 91 minus 75, and I divided by 4, 4 being these 2 standard deviations and these 2 standard deviations, I would conclude that, let's see, this is 16 divided by 4. Oh, I come up and arrive at the same answer. Now, I don't care which way you decide to go about it, but you should be able to show me mathematically how you're arriving at your solution, not just kind of copying your neighbor. All right, let's use these percents. On a standardized test, the mean is 73 and the standard deviation is 7. All right, let's do that. 73. 7 would be 80, 87, 94. 7 would be 66, 59, 52. So those are my numbers. Those are the important part. If 1,000 students took the test, how many scored between 73 and 80? Now, it's really in your best interest to highlight these, 73 and 80. And shade it in, because we're talking about this area right here. So shade it in. We're talking about all of this. Now for this, I can just use my normal distribution curve. So I come up here and I say, okay, what am I really talking about? I'm talking about up 1 standard deviation. So from here, from my mean, I'm talking about going up 1 standard deviation. So this is the part of the curve that I'm talking about. Well, that is 19.1% and 15%. Now, don't think that 0.1 is not important. It is 0.1. It's 10%, right? So where are we? Right here. So we know, we're talking about this area right here. We're talking about 19% and 15.1%. So that's a total of 34.1% in that area. So 34.1%. Now, they didn't ask you what percent, 34.1%. If they asked you what percent are scored between, you'd say 34.1%. What they asked you was how many students. So what we need to do is we need to say, okay, we'll take 1,000 and we're going to multiply it by 0.341. Remember, if I want to convert this to a decimal, I divide by 100, right? So 1,000 times 0.341, it should come as no surprise. That's 341 students. All right, on a standardized test score, the mean is 92 and standard deviation is 3. Pause the video right now and put and label this thing. Now, by the way, you notice I keep giving you this normal distribution curve. I'm not giving you this on quiz day or test day. You got to draw it yourself. You got to create the diagram. I probably should have left a few of these out, so you have to get used to drawing that thing. Drawing it and labeling it. Don't be a tool that thinks you can just do this stuff in your head. It's not going to happen. 95, 98, 101, 89, 86, 83. So I want to know between 89 and 95. 89 and 95. Well, that's one standard deviation up, and that's one standard deviation down. So it's -1 and it's +1 standard deviation. So that's two standard deviations, and we've talked about already that two standard deviations is 68.2%. So what I need to do then is take my 40 students and multiply it by 0.682, and I get 27.28 students. Now, don't be a whack job and give me the answer is 27.28 students. I guess the guy's legs over there took the test. No, the answer will be approximately 27 students scored between 89 and 95. Uh-oh. So we got to do a little bit of work. So let me take a break and get my calculator up. So the following are the ages of employees at a local accounting agency. And so what I need to do, these are all the employees, so what I need to do is get these on my calculator, which I've done already. I've already managed to do that. And I'm going to go through and figure out what the mean, standard deviation, and all that is. So I typed them in, stat calculations, one variable statistics. Okay, I called them ages, and we'll click OK. So it looks like my mean bar does not appear to be right. My mean bar is 5 quadrillion. I'm not sure. Oh, look at these numbers. Let's see if I can get these up. Document settings. Approximate. Make default. Okay. Okay, there we go. All right. It was giving me a fraction. Okay. So my X bar is 57.428. Well, that's so dumb. So my X bar is 57.43, let's say. And notice that makes sense. Somewhere around here, right? 57, somewhere around this area would make sense. And my standard deviation, my population standard deviation, because it didn't say this was a sample, so I got to go down to my population. You notice you're going to be given both sample and population. Notice they're slightly different. You have to use the right one, 10.77. So how many ages fall within one standard deviation? What I'm saying here, this is really X bar plus 1 standard deviation and X bar minus 1 standard deviation. So all I got to do is I'm going to take this 57.43, don't round it, and add 10.77. And I'm going to take this 57.43 and I'm going to subtract 10.77. And when I do that, on this one, I get, let's go with 46.6. And this one, I get 68.2. So how many scores or how many ages fall within one standard deviation? So let's see. 56 does, 56 does, 59 does, 60 does, 67 does. So how many is it? That's 5 scores. So will this be considered normal? Well, how much would be normally distributed? Within plus or minus 1 standard deviation, didn't we say it's approximately normal if we have about 68.2%? So I've got 5 out of 7. See, because over here I got 5, and there's 5 out of 7 are within 1 standard deviation. Now, I don't know what that is as an actual decimal, so let's figure out what that is. It's 0.71%. So this is equal to 0.71, which is approximately 71.4%. And I guess what I would say is this is just a very rough estimate, but since 71.4% is close to 68%, we can say that the ages are approximately normal. This doesn't always work. It's kind of like a general simple rule of thumb, but it works in this particular case as kind of just a getting an idea. Are we close to being normal? All right. Okay, so what we're going to do is this. And this is something I'd like you to try. And then I'm going to show you a calculator feature. Maybe I should be showing you, maybe I shouldn't be showing you. But I'm going to show it to you anyway. A normal distribution has a mean of 33 and standard deviation 4. Find the probability that a selected value from the distribution is in the given interval. So every one of these is 33, and we're going to go up by 4. So 37, 41, 45. Down by 4 is 29, 25, 21. So I'm going to do one, and I'm hoping you pause the video and try the rest of these on your own. I want to know between 29 and 37. That's plus or minus 1 standard deviation. So if I added all those up, that would be 68.2%. That's kind of an easy one. Let me get a weird one. Let's do 5. I'll do 5 with you, and then you try the other ones on your own. I'm going to do them with you, but I'm hoping you pause the video and come back. So this is 33, and I want to get to 29, so I'll go 29 here. At least 29. So at least 29 would be here. This is the least it can be, or anything above. Well, remember, if I fill in all of this, isn't this 50%? Yeah, that's 50%. And then what's this right here? Then what's this piece right here? Oh, we remember that that's 34.1%. So I'll take the 50%. And if you use this table from above, you can go back up here to this table. You say, okay, all of these are 50%. Then I went down 1 standard deviation. Remember, these lines don't represent 1 standard deviation. This represents 1 standard deviation. And this adds up to 34.1. You'll get used to that. So if I take all those and add them up, you can either add them all up or just realize one side's 50% and the other side's 34.1. Add them up, you get 84.1%. All right, you guys try the rest. I'm assuming you're going to hit pause in a second while I take a drink of my coffee. I'll make a funny face for you while you can do it. I hope you paused it during that. All right, let's get going. 33 is the middle, right? And I want between 33 and 45. So 37, 41, and 45. So I want all of this between those two, and I want to stop at 45. So let's see what that is. This is going to be a lot. So I don't want any of this. I want to start here. Now, if I went all the way over, I would have 50%. But I'm stopping right here. So I'm not going to include that 0.1%. So this is really 50% minus 0.1%. So that's 49.9%. And that's what's on this one. 49.9%. You should show your work. 50% minus 0.1% equals. All right, let's do this one. 21. Now, I already graphed it, so 21 is here. And 41 is here. So that's all of this, which is, I'm going to start with 100% because I almost got everything. The only piece I don't have is this 0.1% here. And this is 41 here. And then this is 2 standard deviations. So I got to figure out what this little piece is over here. So I'm going to go up to the top. And I'll say, okay, 2 standard deviations. So I'm going to stop 2 standard deviations up. So that's this. Let's see, 1.7 plus 0.6, that's 2.3%. So down here, I'm going to take 100%. I'm going to subtract off the 0.1%, that's this. And I'm also going to subtract off the 2.3%, and that would be this part down here. So I'm really subtracting off 2.4%, so that means it would be 97.6%. At least 25. All right, so 25 is here. And that's all of this. Now, I don't like doing that. I'm just going to do 100 minus this piece. So that's 100%. Minus 2.3%, which is, what is that, 97.7%. And where's 37? At most 37. So here's 37. That's the most it could be. If that's the most it could be anything down here, right? So we want the probability that x is less than or equal to 37. I probably should write that. Well, this is 50%, and then this is 1 standard deviation, which is 34.1%, so that's 50% plus 34.1%, and that's 84.1%. All right, so now I'm going to show you something that you have to understand what's going on in order to use it, but it's actually relatively simple. So let's grab our calculator, not this. I'm going to grab our calculator real quick, and I'll show you a couple of these. So you go into, let me see if I can shrink this up a little bit. So let's say we are going to do this one right here, the one that's between 29 and 37. So I go to my menu, and I'm going to go into statistics clearly, and we're working with distributions, so I want to go into distributions. And I'm working with normal distributions. So one is, this is a point distribution. We probably won't use that one. This one stands for cumulative density frequency. Cumulative means they add up, and that's what I want to do. I want to add all those percentages up. So I'm almost always going to be using normal CDF, normal cumulative frequency. So what did it say the lower bound is? Oh, my lower bound is 29. What's my upper bound? My upper bound is 37. What's my mu? My mu is my mean, which we said was 33. And what's my population standard deviation? We said my population standard deviation was 4. So if you give it all the parameters and click OK, 68.2%. Now, this is going to be more accurate. Remember, those are all just rough numbers. So, pretty simple. But wait. How am I going to do, well, let's do this one right here. We got between 33 and 45. So we'll do the same thing, menu, statistics, distributions, and normal CDF, between 33 and 45. So 33, 45, still 33, and 4. So hopefully this turns out to be 49.1%. Oh, look at that, 49.9%. I got 49.86%. Really close. Let's check this one, between 21 and 41. Well, once you've done this, now you can just do this if you want. 21, 41. 97.6%. Now, the next one's going to be a little trickier, so let's see how that one's going to play out. We'll do a couple of these tricky ones. I said at least 25. That means 25 or more. So 25 is the lowest we can do it. Now, you're not going to be able to adjust it. You got to do it like this. Distributions, normal CDF. So the lowest it can be is 25. The upper bound is what? It's infinity. It's big, ginormous number. The easiest way to do that is just put in a whole bunch of nines, right? It's just so huge. And it makes no difference. 33 and 4. So if you ever need to put in a lower bound or upper bound, you can do that. The other thing you could do if you wanted to is you could do this. You could do this. You could do 9, and then you can use, where's my scientific notation? I forgot where it is in this calculator. Yeah, I don't even like doing that. Oh, wait, there's an infinity right here. It's in blue. Maybe I can just use infinity. I don't know if you guys have that, though. I don't know if that's on your calculator. I could just use infinity. But easiest way to do it is just go, a whole bunch of 9s. Click OK. There it is, 97.7%. Over here, I wanted at least 29. So I go to Menu, Statistics, Distributions, number 2. At least, what was it, 29? At least 29. Mu is 33. Mu is 4. 84.1. And the last one is 37. So less than 37. How am I going to do this? Menu 652 is the thing. So I want negative infinity. Actually, negative infinity is fine. I don't know if your calculators are actually going to have that. So why don't we use negative 999999999. Who cares, right? And then we want it all the way up to and including 37. 33 is my mean. 4 is my mu or my standard deviation. Click OK, and look at that, 84.1%. So that's how you use your normal CDF calculator for calculating these distributions on your calculator. And that's pretty simple. All right, kids, that's it. Hit the subscribe button, hit the like button. Tell me what you like, tell me what you don't like. Hopefully you learned a little bit of something. Make sure you subscribe to the channel, kids, all right? Adios, amigos. Goodbye.